Until recently, designing for effective sustainment is an objective that has too many unmanaged and independently worked activities. It is an area that struggles with consistency in application during design development and leads to unpredictable rework cycles and costs later in design development and throughout the sustainment lifecycle. This video introduces a scalable and consistent high-level solution to navigate through any of these challenges in a surprisingly simple and straightforward manner for even the most complex systems of today. To do this, we will very briefly touch on the typical design and support disciplines and where DSI's ISDD tools augment the collaboration and value throughout the entire product lifecycle. Central to any consistent process would be the activity that adopts a robust method to capture the data and knowledge from and with the design experts and hold it in a form that could effectively serve to collaborate and cross-validate contribution to the design and support objectives or requirements. DSI's flagship tool, Express, has been up to the task since it was first introduced in 1996, and it's only grown more relevant in more ways since then. So, Express allows you to analyze your design to determine how sustainable it is when fielded, and then allows you to create diagnostics that you can export for actual deployment. We developed a format called DiagML, which allows you to export your diagnostics for use in a variety of independent or commercial applications, and with any capable commercial tools that parse that DiagML and use it. Since reliability engineering is a critical design activity, we also developed the integrated FMECA within Express that allows you to tie actual diagnostics to your FMECA rather than just reliability guesses as to how some things will be able to be detected or how something may be able to be isolated. If you are familiar with 1629A format FMECAs, there are columns in there where you can add written narratives of how you would expect the operator or the maintainer to be able to detect the failure based upon the knowledge from the designer. 10 years ago, we released the first version of Stage, an operational support simulation-based tool that considers how a fielded system will fail as dependent upon how it is maintained. For example, if we wish to assess any mix of predictive, preventative, or scheduled, or run-to-failure maintenance, we can discover what the impact of the diagnostic capability would have on our achieving of any of those goals over any sustainment lifecycle. We'd also learn what the costs are expected to be in terms of any of the other four goals: availability, safety, operational success, or cost of ownership. Stage allows for extensive simulations that will expose many hidden weaknesses. RTAT and Express Design Viewer. One is the introduction of our runtime authoring tool, which created the files that our design viewer can read and allows you to distribute Express data and diagnostics on computers that don't have Express installed. The Express Prognostics module enables the assessing of the value of prognostics so it could be performed in a more objective and manageable environment. Several key reports are generated in Express that can point out areas of the design that may or may not benefit by an investment into certain prognostics endeavors that are not otherwise so obvious to the customer or the PHM expert. Combined with Stage, simulation-based assessments are able to collectively consider the maintenance requirements along with the diagnostic acumen of any proposed health management technology. That was followed shortly by our release of our DSI Workbench, which is our full-featured diagnostic client that allows you to perform Express diagnostics in the maintenance or production environment. And that's being used around the world on ATEs, desktop computers, maintenance facilities, and even on vehicles. It has really taken off. And with that, we also developed the History and Feedback module, which allows you to track information not only about your expected diagnostic outcome and maintenance, but also your unexpected outcome. DSI Workbench provides you with both your engineering diagnostics as well as empirical diagnostics based on what type of things have been found to be the issues. So between the two types of diagnostics side by side, unique to DSI Workbench, you are really able to have a powerful and all-accepting approach to maintaining your system. The maintenance module in Express allows you to tie together different levels of diagnostics, among other things. So you can actually take all the information that you have learned during embedded diagnostics and encapsulate it into a single fault code. Then, when loaded into a maintenance facility, ATE, IEDM, or workstation, it provides extensive diagnostic knowledge in order to effectively isolate the failures as learned or bridged from that previous onboard or health management diagnostic technology. The bridging of the diagnostic conclusions from onboard to offboard is far more effective than otherwise. Starting the offboard testing environment with the typical vagueness of bit test results, currently degrading the effectiveness of too many sustainment practices not considering diagnostic information sharing. The FTA module, companion to the FAMICA module, is taking the actual diagnostics and incorporating it into a different type of analysis, the fault tree analysis for safety and risk assessment. Now it can be used by incorporating the diagnostics to actually evaluate the impact of ineffective diagnostic or prognostics design upon the risk of successful operation of your system, among many other things. Then with the desktop fault insertion, or DFI, in Express, we introduced an advanced diagnostic validation capability to ensure accuracy of diagnostic inferencing to support the operational onboard bit and offboard test coverage for required maintenance demos. The D-matrix export was recently added to basically support older technologies. It can be useful in other internal applications or in adding innovative processes. The Express Embedded Reasoner continues to take advantage of the investment put into the design and support activities by providing another high-end, back-end diagnostic reasoning option. This embedded reasoner is the first commercially available model-based diagnostic reasoning tool that is a plug-in reasoner, ready to be integrated with your existing and preferred onboard health management system. The Express Embedded Reasoner is provided with the source code, so you can use or modify any portion for any specific application. The Express Dynamic Reasoner, which is basically taking the Express algorithms that are created within the companion Express Dynamic Diagnostics module to prep the data in a unique form. So, when transferred to the DSI Workbench Reasoner, it can build diagnostic sequencing on the fly. This is a key component when the availability of adequate resources is unknown, yet the most effective diagnostics can still be delivered to any skilled technician based upon the criteria at that time. We have an ExpressML module, which allows you to import data from a variety of sources as more programs are becoming more attracted to the advantages of model-based systems engineering. Through our innovativeness and successes in extending collaboration and interoperability, you can be among the first to infuse diagnostic acumen into outputs from capable MBSE tools, and thus repurpose existing investment into additional full product lifecycle value. This process is optimized by using ATML-Pad as a key component in the Design Import Manager to parse from various different formats, such as SysML, ATML, and DiagML, into ExpressML, and map inversely from one format to the other by using the one versatile translator. And, finally, the Design Viewer Redline module, which allows people in other engineering activities or parties to mark up as needed and provide documented feedback into the whole process. Here's where everyone can easily contribute and oversee progress as a design moves forward. In summary, designing for effective sustainment is an incredibly rewarding objective. The course is mapped, now it's over to you. Please be sure to see the videos on any of these tools or capabilities by visiting the video library on the DSI International website.